Okay, welcome to another episode of Glide Up in Mathematics with Mr. Shadi. So today we'll be exploring applications of the laws of indices. Applications of the laws of indices. We have about 7 major laws of indices that you need to know. We have the multiplication law, which is y raised to power a times y raised to power b equals y raised to power a plus b. When the exponents are multiplying, you add the powers together. Y raised to power a divided by y raised to power b will give you y raised to power a minus b. That's the second law, division law. And the third law is the zeroth law. Whatever, any number or letter raised to the power of 0 will give you 1. 1 million raised to power 0 will give you 1. X raised to power 0 will give you 1. Y raised to power 0 will give you 1. We also have the negative index law. When you have a negative index, all you need to do is to take the inverse. You take the inverse. For instance, you have 5 raised to power minus 2. So you take the inverse, which will be 1 over then 5 raised to power 2. So the inverse takes care of the negative sign. Then you have your normal 5 raised to power 2, which gives you 1 over 25. So you can as well say a fraction raised to a negative index. You can invert that fraction and the power becomes positive. So what do I mean? For this law number 4, we have 2, or let's say you have 2 over 3 raised to power minus 2. So this is simply 3 over 2 raised to power 2. So as soon as you invert the fraction, then your power changes to positive. So that is that about that. You have the double index law too. Double index law, y raised to power a certain number, then raised to power another number. All you need to do is to multiply both numbers together, the powers. So you have the number 6, which is the inverse power. Y raised to power 1 over a. When you have a number raised to power a certain fraction, but the numerator is 1. So in this case, your denominator here will be the root of that number. Simple. So what does that mean? If you have 9 raised to power half now, for instance, this means it is the square root of what? 9, but in most cases they don't write 2 here because it's square root. So and square root of 9 equals 3, plus or minus 3 anyway. So you can have 9 raised to power, and let's say you have 27 raised to power 1/3. So this 3 here becomes your root. So that takes 3 root of 27 or cube root of 27 raised to power of 1, and that is 3. It means the number you multiply by itself 3 times will give you 27. So this is not my main focus for today. I just need to explain all these simple laws. The last one, y raised to power a over b. When you have a number raised to a fractional index, so the denominator takes the root of that number, then the numerator becomes the power. So if you have, let's say you have 8 raised to power 2 over 3. So this 3 becomes your root. That is cube root of 8. Bracket it, then raised to the power of 2. Are we together? So cube root of 8 means what number will multiply by itself 3 times, that will give you 8. And that is 2. 2 times 2 times 2 will give you 8. So you have 2 squared, which is 2 times 2, which is 4. So I hope that is clear. So let's go to the main application. The questions I want to solve. This will be useful for learners that are preparing to write external exams from grade 6 to grade 12. So when you have questions like this, how do you solve it? I used to advise students that when you have question given to you in this format, it will be easy for you to change the division line, change it to the division sign. This will be divided by 27 raised to power 2 over 3. So you can rewrite this in index form. You can also rewrite this in index form, and having them maintain the same base. How do I mean? 9 here can be rewritten as 3 squared. You can bracket that, raised to power minus half. Then divided by 27 can be rewritten as what? You can rewrite it as 3 raised to power 3. Bracket that, then raised to power what? 2/3. So going by our double index law, when you have y raised to power a, then raised to power b. Don't forget we said this is y raised to power a times b. The two powers will multiply each other. So let's apply that here. So this will be 3 raised to power 2 times minus half. Then divided by, this will also be 3 raised to power 3 times 2/3. So 2 here, 1, 2 cancel 2 here. So here you are left with 3 raised to power minus 1 divided by 3 here, 1, 3 cancel 3 here. So we have 3 raised to power what? 3 raised to power 2. So at the end of the day, 3 raised to power minus 1, that is negative index. You take the inverse, that is 1/3. Divided by 3 squared is 3 times 3, which is 9. This is 9/1. So when we flip the other side, we change to multiplication. To flip the other side, we have 1/9, and this gives me 1/27, which is my final answer. So I hope that is clear. Alright, we'll look at another question. Let's look at another question here. So I have 16. Okay, let's say this is question 1. Question 2. Simplify. 0.027 raised to power minus 1/3. We have this question. The first thing is to change this 0.027 to fraction. Change it to fraction, and that becomes 27/1000. How is it 1000? The decimal point will take 1, another digit will become 0. So that is how you arrive at that. So 27/1000 raised to power minus 1/3. So we need to get rid of that negative power, and we need to change it to positive. And I told us we can change it to positive by inverting the fraction. So this is 1000/27 and raised to power 1/3. So easily, any number raised to power 1/3 is the cube root of that number. So you can easily take the cube root of 1000/27. And what this means is cube root of 1000 divided by cube root of 27. Which number will you multiply by itself 3 times? That will give you 1000. That is 10. 10 times 10 times 10 will give you 1000. Which number will you multiply by itself 3 times? That will give you 27. That is 3. So at the end of the day, you get 10/3, which is 3 whole number 1/3. So I hope that is clear. So laws of indices and applying it is very, very simple and easy, provided you understand the law. So we look at another question, question 3. It says simplify. Simplify 5 raised to power minus 3x equals 125. So when you are dealing with indices, numbers that have indices that have negative power, and you have an equation, how do we solve it? For this now, we find a way to make sure that we have the same base on both sides of the equation. So 5 raised to power minus 3x will be what? 125 becomes 5 raised to power 3. 125 becomes 5 because 5 times 5 times 5 will give you 120. So you can replace 125 by 5 raised to power 3 so that we have the same base. So once the two bases are equal, then they can cancel out because it means that the powers are also equal. So since the bases are equal, we then equate the powers. We equate the powers. So what that means is that 5 can cancel 5, so minus 3x will be equals to 3. So you divide both sides by negative 3, that is the coefficient of x. We have minus 3x over minus 3 equals 3 over negative 3. Just cancel this. So x is minus 1 as the value of x. So let's look at one more example before we call it a day. Let's look at one more example. Okay. We have example 4. Simplify 27 raised to power 2x plus 1 equals 3 raised to power x minus 1. Questions like this do come out in W.A.S.C.E, Cambridge exams too, IGCSE. So how do you solve questions like this? Applying law of indices is the same way. Make sure they have the same base. So find a way to represent one of both sides to be in the same base so that you can equate it and you can cancel out and equate the power. So we can rewrite 27 as 3 raised to power 3. That represents 27. Put it in bracket. The power remains there, 2x plus 1 equals 3 raised to power x minus 1. So according to double index law, these 3 can multiply this index out. So we can have 3 raised to power 6s plus 3 equals 3 raised to power s minus 1. So since the bases are equal, this can cancel this out. Then we equate the powers. So 6s plus 3 equals x minus 1. So we can now use the balance method and we get our x. So this we go here, meet x, bring the same member of family together, 6s minus s equals, this will come and meet this one here and becomes negative 3. So 6s minus 5x, 6s minus s becomes 5x, which equals to what? Minus 1 minus 3 is minus 4, negative 4. So divide both sides by 5 to get s. Divide both sides by the coefficient of s, which is 5. So you have 5x over 5 equals minus 4 over 5. 5 cancel 5. So your x is minus 4 over 5. Call it a demonstration. So, as the applications of laws of indices, and I hope this video has done justice to the fears you have in solving questions relating to indices. You can go over it again and again, and you find out that it's very easy. Thank you for your time, and see you